Caution: this video is for educational purposes only. We assume no liability for injuries or damage caused by imitating the experiment. Please observe the legal regulations that apply to you when handling chemicals. Preparation of Fremys salt. Potassium nitrosodisulfonate is a strong oxidizing agent used, for example, in the oxidation of phenols to ketones. The oxygen radical of the nitroso group makes it extraordinarily reactive and, unfortunately, also relatively unstable. It can decompose abruptly at any time with strong evolution of gas. At best, it can be kept open under vacuum in a desiccator for a few days, but never in sealed bottles and jars. Since we only produce the substance for demonstration purposes and otherwise have no direct further use for it, we limit ourselves to the smallest possible scale and then neutralize the product again directly. A solution of 0.86 grams of sodium nitrite in 2.5 ml of ice water is added to 5 grams of water ice. Then a solution of 1.19 grams of sodium metabisulfate in 2.5 ml of ice water was added with vigorous magnetic stirring. Finally, 0.5 ml of glacial acetic acid is added dropwise. Alternatively, an amount of vinegar essence adapted to the concentration can also be used. After the ice has melted and the beaker has been transferred to a bowl with ice-salt cooling mixture, 1 ml of a 10% ammonia solution is added to the reaction solution while stirring continuously. The pH of the solution is controlled, should be around 9 and remain so throughout the whole following reaction. Maintaining a basic pH and temperatures below freezing are essential for the synthesis to succeed. In the following, a solution of 0.65 grams of potassium permanganate in 10 ml of water is slowly added using a dropping funnel. Both the amount of permanganate and initially of nitrite correspond to a 100% excess, which is necessary because significant proportions of the starting materials and intermediates already decompose in the mixture before the desired reaction occurs. If, as in our case, gas development is noticeable through hissing, which indicates the beginning of decomposition of the end product, the addition of permanganate must be slowed down or interrupted immediately. The pH value checked and, if necessary, corrected with additional ammonia, and the temperature be lowered by adding small pieces of ice into the solution. After we succeeded in doing this and the decomposition was thus prevented, the addition of permanganate could slowly be continued until everything was dripped in. The mixture is then filtered. The filtrate is, as you will see at the end, no longer colored violet by the permanganate, but by our end product. All permanganate has been converted to manganese dioxide, which remains in the filter as a pasty brown mass. A solution of 7 grams of potassium chloride in 20 ml of distilled water is then added to the filtrate. Our end product should have crystallized out in the next few minutes, but this apparently didn't happen, even after the flask was placed in the cold mixture. So we decided to induce precipitation by adding 50 ml of ethanol, which actually worked, but not in the product color that would have been expected. Just as we were about to discard the batch and had transferred it into a larger beaker for neutralization, the white precipitate slowly turned yellow, while the originally violet color of the supernatant slowly faded in favor of even more yellow precipitate. So there we have our free radical built-in component after all, potassium nitrosodisulfonate. The following processes took place during the synthesis. First, metabisulfite is readily hydrolyzed in water to hydrogen sulfide. In the next step, the nitrous acid formed from acetic acid and nitrite reacts with hydrogen sulfide to form hydroxylamine N and disulfonate. Thereafter, hydroxylamine N and disulfonate is oxidized in an ammoniacal environment with potassium permanganate to form the radical nitrosodisulfonate. After adding potassium chloride solution, the potassium salt of nitrosodisulfonic acid, which is unknown in the free state, is finally formed. Our product is then filtered off and rinsed once each with ice water and ethanol. Since gravity filtration is quite slow here, it is advisable to use vacuum filtration for larger batches. After filtration, the filter cake on the unfolded filter paper is covered with a second sheet of filter paper and thus pre-dried by squeezing between two thick layers of paper towels and exposed after turning and peeling off. Finally, after a few hours of open drying, we obtain 0.92 grams of potassium nitrosodisulfonate, which corresponds to a yield of 57.2% compared to the theoretical possible value. The nice yellow color of the substance is already remarkable in itself, since the color is otherwise only known from organic dyes or inorganic transition metal salts. If the yellow powder is dissolved in water, the violet solution is formed again. In the crystal lattice, the nitrosodisulfonate anion is present in dimeric form. In aqueous solution, it dissociates into two radical anions. This explains the violet color of the solution, whereas the crystals are colored yellow. To neutralize the radicals for disposal and to demonstrate how acid sensitive the compound is, we add some semi-concentrated hydrochloric acid. After shaking, the solution discolors very quickly. A gas development is not recognizable. I did not find any information about the decomposition products in my literature sources either. If you know which colorless substances are created here, please write it in the comments. Thanks for watching. Be back for next Sunday's video. If you liked today's video, please subscribe to our channel. Ratings and comments are welcome too. If you'd like to see a specific experiment, post it in the comments and we'll see what we can do.